Hi. So yeah, as part of the Zupass team, Richard and I have both been working on some kind of developer-facing components. So you might already have seen the user-facing aspect of Zupass if you've checked in with your ticket here, or if you've collected any frogs in PROGCRYPTO. You've kind of seen something about what the Zupass app can do. But we also provide a set of software libraries, so basically an SDK that allows you to integrate your own applications with Zupass. In particular, that allows you to have Zupass-based authentication, so someone can authenticate into your app on the basis of having a ticket, for instance, a Zuconnect ticket or a Devconnect ticket, a PROGCRYPTO ticket, or on the basis of having, for instance, a frog, or perhaps even a particular frog in your frog collection. There's also tools available for issuing your own PCDs, so issuing your own tickets or issuing your own kind of frog-like things. Perhaps you could come up with iguana crypto or something like that. And we've been trialing this over the last few weeks with two different ecosystems. How do I click on just this? Yay. So we started a few weeks ago, and some of you will have been there at Zuconnect, which is a 400-person event here in Istanbul with multiple different types of tickets that people were able to buy and then use to check in, day passes, week-long passes, hacker tickets, and so forth. People were scanning in every day using those tickets, and they also had access to the same things they have here at Devconnect, so there's a gated telegram and a polling service, Zupoll. And one of the main events at Zuconnect was the Hack Zuzulu hackathon, where people were building their own projects, and multiple projects there were built that integrated Zupass. In particular, Zoo Astro was one of the winning projects, which allows you to store your star chart in Zupass and then kind of make connections with other people using your star chart. So if you're a Libra and they're a Pisces, I don't know if those go together well, but like you find out, you'd be able to kind of like, exchange information, and it would tell you on the basis of your star chart, it looks like you're kind of compatible, which was a nice use of that service. Lemonade also issued tickets to people, so they actually built a system where you could sign something using your Ethereum wallet, upload that signature into Zupass, and then it would produce tickets for you based on the NFTs that you hold. So if you held some NFTs, you could then kind of get a representation of the fact that you hold them. In Zupass, you get the QR code and have that scanned by people. There's also another winning hackathon project was distributed trials, which allowed you to join a medical trial. So you could have a wearable device. They had these special wearable devices that you could carry around with you that would measure things like your heart rate and so forth. You could then participate in dietary interventions. At the end of that process, you could then sign in and upload your data, and you could prove your membership of the trial. So you could prove that you were someone who had signed up for the trial when you submit your data, but you don't need to identify yourself as an individual participant. So at the end of that process, they get data back, but that they can see does come from authentic trial members, but without being able to say, like, this data came from this specific person. Also a very interesting one was Zupass Unlock, which basically did a kind of red teaming of Zupass. So they went through and looked for security exploits and various kind of hacks and tricks that they could use, which was really, really helpful. That was a great insight for us as a team to see that, and it was good that they disclosed that in a responsible way. So if you're interested in doing this, there are a couple of libraries available that you can look at. There's ZooAuth, and I'm not going to talk too much about that because the next talk is going to focus on this. So if you're interested in that, definitely catch the next talk. And also Zupass Feed Server, which is an example server that serves tickets or other PCDs up to people. So it gives you a basic idea of how you might be able to issue your own tickets using Zupass. And now I'm going to hand over to Richard to talk about the Devconnect ecosystem.
Cool. So you've all been at Devconnect for 5 days or so now. So you might have seen some of these Zupass-based interactions. Obviously, you had to use Zupass to actually get into PROGCRYPTO. But here's just a bit of an overview of the other applications that have built on top of Zupass and use sort of ZK applications in that way. So kicking it off with Austin Griffith, who built Scaffold ETH. So one of the things that he and his Scaffold ETH team did was extend Scaffold ETH with a few additional functionalities, right? So it's kind of hard to see on this screen right here. There's a lot of moving pieces, but essentially what the starter pack that he builds allows you to authenticate using Zupass, submitting a proof of valid ticket, and then doing a few actions. For example, verifying it on the front end, but also verifying on a server and sending over 1 ETH. And also we managed to get on-chain verification. So have the verifier, which is just a ZK EDDSA proof, be verified on-chain and then mint you an NFT, right? So this starter pack, just pretty exciting stuff to get out there, and you can view this tweet and watch a sort of run-through video to learn more about this. So this wasn't actually built with the starter kit, but you might have seen this tweet around. This is Philip, and he's built there's a new testnet called WholeSky, and as they're launching one of the faucets, they're thinking about a good sort of Sybil-resistant way to distribute the Ether. Formerly, they had done things like proof-of-work mining, but in this case, they realized that, we could just basically have Sybil resistance if we gave this to everyone that had a Devconnect ticket could only claim it once, right? So that's exactly what this is. You enter your Ethereum address or ENS on this webpage here, you log in with your Zupass, you send the request. There's also a CAPTCHA to prevent sort of, botting and stuff like that, but it's actually not necessary. You start mining, and then within 10 seconds, you should receive 500 WholeSky or Sepolia ETH. And we actually had a few teams, so like Lattice, for example, who's doing autonomous worlds, use this very faucet and discover this very faucet, like totally not even through, the Zupass connection, because of just how, useful it was. Another example of this kind of faucet mechanic is the Dymo team, who is building an open source USDC-based wallet. And one of the things they have is, you can scan this QR code too if you're curious, but you can log in with your Zupass in order to get an invite code to the sort of mainnet launch of Dymo. It's another example, again, of how a faucet or initial seed is locked behind a ZK proof. So one of these things you might have seen circling around is ZooPoll. So this is used a lot more at Zuzulu and ZooConnect, but we have a concept of organizer polls, which organizers' events can create, or community polls where anyone in the event can create. For example, it's like, we'll have questions like, how's the feedback on the vibe of the venue, right? A community poll might be like, is a hot dog really a sandwich, right? Or what's your favorite color? This is just, again, kind of a fun, low-stakes example, but this was used to make real town hall decisions at Zuzulu, and it's just another way, if you kind of read the text here, what happens is your Zuzulu identity gets added to a semaphore group. That group is locked. The Merkle root hash is locked, and that way you have anonymous voting, and all done through sort of a web app, either within the Telegram app or within a browser. Yeah, so this is what you actually see. This is what you actually see when you create a Zupass proof, and I think all of you should have seen this if you've joined the PROGCRYPTO Telegram group or the Devconnect Community Hub, right? It looks kind of like vaguely like an OAuth screen, right? But essentially what it's asking, what it's saying is, here's what you're making a proof of, your ticket here, your PROGCRYPTO ticket. You are revealing only this subset of fields. So in this case, you're only revealing your semaphore ID, which is like your public key. And the reason that we need this is just so we can have a mapping between your Telegram username and your Zupass identity. And this is another, like Austin's next project, basically, where it should be launching sometime today, but it's essentially a fun game where you can trade fruits. And they're using Telegram bots as sort of the front end to interact with this, and you basically get your initial faucet onboarding tokens via Zupass. Yeah, that's all for now. You can reach us here. You find people in the frog hats, although not all of them are contributors to Zupass. Or reach out. We have a Twitter account now if you want to ask some questions. But yeah, we'd love for you to build on top of us, or just do anything related to Devconnect the remaining days we have now. Cool. I guess we have like... So we have like some time for questions. 10 minutes, okay. Went that fast. Yeah,
Can you tell us a little bit more about the faucet?
Yeah.
Because like we have all these problems when we try to distribute the work to hackers. We don't have the like even testnet ease, right? So
yeah. Can you go back to the slide? Or my thing isn't working. Okay. Anyway. Nice. Okay. So for this one, for example, the way the faucet works is like generally how a faucet would work is you have some kind of server where you have like the private key of some account that holds a lot of testnet ETH or whatever token you want to give out for, and then given some like authentication, maybe it's like for some it's like proof of submitting a certain tweet, right? There's also things like actual proof of work, right? If you figure out what the pre-image is to a certain hash. So in our case, the sort of proof of work is submitting a valid ZK proof that you have a Devconnect ticket. So a Devconnect ticket is just a EDDSA signature, right? EDDSA signatures that are signed by the Devconnect EF server, right? So these are like attested to by the Ethereum Foundation. And EDDSA signatures are easy to make ZK proofs out of, right? So then we create a proof that basically says, this is a valid event. It is one of the 9 event IDs that are using Zupass during Devconnect, and I'm going to reveal certain things such as my semaphore ID, but nothing else. And the signer of this EDDSA ticket is the EF server. This is a public key, so it's published. So essentially this proof is sent over. We have a library called ZK EDDSA event ticket PCD, and then we call the .verify. That goes through. And then we also check various other things. We check to make sure that the items within that claim are actually what they claim to be. And then finally, once that verification is done, it's just like a Web 2 verification. And then we can go ahead and send ETH, right, using the private key on the server. So I actually don't know that that's 100% what this is doing, but that's one way to do it. The fully like on-chain method, which I think is pretty interesting too, is you have all this happening within a smart contract, right? So there's a smart contract Groth16 verifier that you call verify with the inputs and a couple of those checks. And then after that's done, you can do this, you can send, you know, the balance within the smart contract, right? So those are 2 different ways you can go about having a faucet for now. Yeah, everything I mentioned, me and Rob mentioned are open source. Yeah, you can find us at github.com/proofcarryingdata, no spaces, /Zupass. Yeah, Sam?
Could you maybe expand on... Thanks. For this smart contract faucet example, yeah, to like prevent double dipping into the faucet, is it using some like semaphore nullifier to prevent that, or like what might that implementation look like?
That's a really great question, and actually it's a reminder because I was going to go over that a bit. But yeah, it depends on the level of like privacy/anonymity that we care about. So one thing, okay, to go from like 3 stages, like most, you know, public to most private, right? So most public, what you could do is require the user to reveal their email, right? So that's one of the options that you can configure here, right? So there's like a field called reveal attendee email. You could set to true. And in that case, then you store essentially some kind of mapping of like email to Boolean, right? Like a solidity mapping or something like that. And then you mark it as true. And then in the smart contract, you check to make sure that they don't have a mapping first. And if they do, then you reject it because it's like, you've already done this, right? You can't double spend. So that's most public. So, and then getting one more level of privacy in, we have revealing your semaphore ID, right? So semaphore ID, it's something that's stored on the Zupass server. Like, we'll be able to know what your email is, but the application, the smart contract, right? People that are viewing Ethereum won't be able to see what your email is, right? And the semaphore ID is just kind of like, yeah, roughly speaking, it's the commitment, the public commitment of a semaphore, which is kind of like a public key, right? So it's not de-anonymizing in the sense of people can directly figure out who you are, but any other like transaction you do is also tied to this, is usually also tied to the semaphore ID, and developers of Zupass will also know like who you are, essentially. The most private is you cannot reveal any of this, but then you can reveal a thing called a nullifier hash, which is something that's semaphore specific. And a nullifier hash is kind of like basically like a identifier, a deterministic identifier that's like linked to your semaphore ID, but is not like traceable, right? So if you have a nullifier hash, you cannot derive the semaphore ID and vice versa, right? But it is deterministic, right? Which means that people can't, have the same semaphore count, create two different nullifier hashes, given like one specific constraint, right? So essentially that's how you can have a faucet or a smart contract or NFT minting factory that ensures you don't double spend while not revealing anything about your email or your public key. That's how.
Nice. And like, I guess quick follow-up, as like a developer building a web app for such a faucet, I could use the Zupass SDK to like determine what information the user will reveal. Like if I did want the email check or the semaphore ID, that'd just be something I would put in the web app essentially.
Yeah, that's exactly right. So essentially everything within this like box right here comes from this thing called PCD args, arguments, right? And one of the arguments is this like mapping, like JavaScript object, where you just have like the different items you could reveal, like reveal attendee email, reveal semaphore ID, reveal event ID, and Boolean, right? So in this case, we have reveal attendee semaphore ID as true and everything else is false, right? But it's essentially like a bitmap, right, for which fields to reveal. Okay, I think it is, one more, and then we'll have to finish up.
Just a quick question. So if I wanted to use this Zupass authentication on different chains, let's say L2s, what kind of infrastructure dependencies would I need to provide?
Yeah, so it depends on what you mean by use Zupass, but if you want to like verify a Zupass proof, right, specifically a proof of EDDSA ticket, which is all the examples we've done here, what you'd have to do is take the contents of the sort of on-chain verifier that we have in this project, and you could just deploy it onto an EVM-compatible chain, right? For non-EVM-compatible chains, you'd have to figure out how to deploy some kind of on-chain verifier,